welcome back to this Further Maths Walking Talking Mock. This is part 4 and we've got just 2 questions left, but they're quite, look how much space they give you for them. That means they're probably going to be difficult. But let's have a go. So 16, it's not focusing properly. I don't know how you make it focus. Oh, there we go. By factorizing fully, simplify this. Okay, so we just have to factorize. I say just, okay? I don't know if you've noticed, but these are Cortex. You have to factorize some Cortex. Okay, the top is going to be kind of easier because I can see that x squared is a common factor. So I'm going to take x squared out as a common factor of the top, which will leave us with x squared minus x minus 2. You know, I'm not even going to bother with the bottom right now. I'm just going to focus on the top. Let's factorize that, assuming it will. Minus 2 plus 1. Right, and this is kind of a clue usually to how you're going to factorize the other thing, because you know that some stuff is going to have to cancel out. So let's look at the bottom. Now, right, this is something that we haven't really looked at yet, but this is a quartic, but it kind of looks a bit like a quadratic. Yeah, it kind of looks a bit like this quadratic. Kind of looks like that, okay? But instead of x and x squared, we have x squared and x to the power 4. So imagine if instead of x here, we had x squared. So we had x squared squared minus 5x squared plus 4. Can you see that that's actually the same as that? But instead of it being x, it's x squared. So it's exactly the same as a quadratic, but instead of x, we have x squared. We're still going to factorize it the same way that we would factorize a quadratic. The only difference being that instead of writing x here, we're going to write x squared. Okay, and everything else is the same. It's still going to times to make 4. It's still going to add to make minus 5. So that's going to be minus 4 and minus 1. Okay, then we've got x squared minus 4, which is a difference of 2 squares, x plus 2, x minus 2, and we've got x squared minus 1, which is a difference of 2 squares, so we've got x plus 1 and x minus 1. So this is a mess. Let me write this properly. Okay, so we've got x squared x minus 2 over x plus 1 over x plus 2 x minus 2 x plus 1 x minus 1. Let's do some crossing out. Cancel that one with that one and that one with that one. So we've got x squared over x plus 2 x minus 1. And the examiner's report says oh wow, some students cancelled x to the power of 4 from the top and the bottom. That's, wow. The numerator was often handled quite successfully, removing the common factor of x squared and then factorizing the resulting quadratic in x. Factorizing the denominator was less well answered because many students chose to factorize the first 2 terms as x squared minus 5, and then incorrectly decided that the x squared factor obtained would cancel with the x squared factor in the numerator. A significant number of students spotted the best way to handle the denominator, namely by factorising it first as a quadratic in x squared, then applying the difference of two squares. So sounds like this was not particularly well answered in the denominator. But actually, just doing the numerator correctly would give you how many marks? Let me just see. 1, 2. Yeah, you'd still get 2 marks out of 5 if you only did the numerator, so it's not bad. Alright, last question. Prove that 2 tan squared theta plus 1 is identical to 1 plus sine squared theta over 1 minus sine squared theta, where sine squared theta is not equal to 1. Right, as of today, which is the 21st of April, we have not done any kind of trigonometric proofs in class. So this will be a new experience for you. Do you remember on the first page of the paper, it gave us a couple of trigonometric identities, which is that tan is sine over cos and sine squared plus cos squared equals 1. We might need to use those. So we're going to start with the left-hand side because that's how you should always prove this kind of thing. And I'm going to change the tan squared into sine squared over cos squared. Remember this rule here? Tan is sine over cos. The reason I'm doing that is because the right-hand side doesn't have tan in it, it has sine in it. So it makes sense to me. So the left-hand side equals 2 sine squared theta over over cos squared theta plus 1. Then let's make that into a fraction altogether. So I'm going to incorporate the 1 into a fraction. So I've got 2 sine squared theta over cos squared theta plus, if I times 1 top and bottom by cos squared theta, like that. So now I'm going to add these two together. Like that. Okay, now do you remember here sine squared plus cos squared equals 1? Now on the top I've got 2 sine squared plus cos squared, so I've got a spare sine squared, but one of the sine squareds plus that cos squared is going to equal 1, so I'm going to change that into 1, which is good because we've got the numerator already, so we're almost there. Okay, and also, if sine squared plus cos squared equals 1, then that means that cos squared equals 1 minus sine squared, if I subtract sine squared from both sides. So actually, that cos squared on the bottom, I can replace with that. I should probably write that, because this is a proof, so I should communicate. Sine squared plus cos squared equals 1, therefore cos squared equals 1 minus sine squared. So that equals 1 minus sine squared, which is the right-hand side. So that is proved. I just want to communicate a bit better up here. I changed the tan into sine squared. I should probably just, because tan squared equals, because tan equals sine over cos, just to give them a reason for why I was allowed to do that. And there we go, that's the end of the paper. Let me read the examiner's comment for that question. It says, this question was not well answered. Working from both sides of the identity is verification, not proof. Okay, so some people, yeah, and I know a lot of people do this. Try and like solve it like it's an equation. So like take away 1 from both sides and then square root both sides, something like this. A proof requires students to start from one side of the given result and work their way through to the other side using correct manipulative techniques. Many students started from the left-hand side by writing tan squared is sine squared over cos squared, good, but often made no further progress. Alternatively, starting from the right-hand side, because you are allowed to do that. I started from the left because that's conventional. You are allowed to start from the right-hand side, mess around with it, and end up with the left-hand side. That's fine as well. But it said starting from the right-hand side and writing cos squared for 1 minus sine squared was a good first step, but didn't often lead to a solution. Starting from the left eventually requires terms to be written over a common denominator, yeah, like we did here. Starting from the right eventually needs terms to be written as 2 separate fractions. I see. So if you were going this direction, you'd have to realise from here that you could split it into 2 fractions. And that's kind of more difficult in a way than combining 2 fractions. There were more non-attempts for this than any other question, which makes sense because it's the last question on the paper. You might have run out of time, and also you might just think it's 3 marks, but look how big the answer space is. It's not worth doing. I wouldn't recommend that as a strategy, but if you've run out of time, this is not a priority question, in my opinion. Anyway, that's the end of the paper, and hopefully you didn't think it was too bad. I personally thought, apart from that circle, angle, geometry question, I thought it was all pretty nice. Anyway, I'll see you next time for another walking, talking mock. Bye!